Scientists continue to discover new planets falling into the category of super-Earths. These are a class of planets more massive than Earth but much lighter than gas giants like Uranus and Neptune. Super-Earths can be rocky, gaseous, or a combination of both. They often have a volume twice that of Earth, but sometimes can be up to 10 times larger. These planets are fascinating to study, but they are too far from us for thorough analysis. However, they represent a fairly common category of planets outside our solar system, along with other interesting types like mini-Neptunes, gas dwarfs, ice giants, and huge rocky bodies. There's nothing like super-Earths in our solar system, but we have something others don't: Jupiter. It's the largest and heaviest object orbiting our Sun. This gas giant possesses a massive gravitational force capable of dominating our solar system. Jupiter is known for eating planets. A protoplanet collided with Jupiter about 4.5 billion years ago when the giant was still young. This protoplanet was 10 times more massive than Earth and was made of ice and rock. The impact was devastating. Jupiter's core fused, helium and hydrogen mixed with denser materials. Over time, heavy material redeposited into the core, forming what we see today. This event happened in the past but could happen again in the future. Scientists hypothesize that our solar system had many more planets in the past than it does now. In fact, there is a lot of space around Mercury, while many other central stars have a larger number of intermediate mass planets, with sizes between Earth and Neptune. Originally, our solar system was a chaotic place. Young stars were surrounded by swirling disks of dust and gas that eventually formed planets. Similar to trees sprouting from the ground, small rocky planets would have formed in the hot zones near stars, while gas giants formed farther out, where temperatures were lower and gases could remain trapped in their atmospheres. Even though the planets in our solar system seem stable and quiet today, each with its own well-defined orbit, they were not so peaceful millions of years ago. Some planets had eccentric orbits that brought them closer to and farther from their stars. Their orbits seemed disturbed by the gravity of other planets along their path. There's a theory called the Grand Tack hypothesis that explains events in the first few million years when our solar system was forming. Shortly after its formation, Jupiter, one of the main characters in the story, would have migrated inward in the solar system, then returned to its normal orbit by crossing the current asteroid belt like a sailboat tacking around a buoy. This event disrupted the formation process of other planets. After Saturn formed, the area around the two gas giants was cleaned up. If the Grand Tack idea is correct, Jupiter would have attracted and engulfed all the material it encountered in its path, and its migrations would have caused a huge number of collisions. That's why some planets were destroyed and eaten by Jupiter. It might also be responsible for bringing water to our planet. Thanks to its gravitational attraction, it was able to change the trajectories of numerous comets and asteroids that passed through its space. It may also have participated in the extinction of the dinosaurs 66 million years ago by bringing a space rock to Earth, leaving a crater off the Yucatan Peninsula in Mexico. An impact that caused earthquakes, volcanic eruptions, and tsunamis had a huge impact on all animal and plant life on Earth. No one knows where the impacting object came from, and we're not even sure if it was an asteroid or a comet. One theory suggests it might have been a comet from the Oort cloud, an area at the edge of our solar system with a very high concentration of comets and asteroids. An icy body might have been knocked off course by Jupiter's enormous gravitational force. In practice, our solar system resembled a cosmic pinball machine, where Jupiter, the largest planet, diverted comets passing through its zone toward the Sun. When these comets approached the Sun, they were shattered by gravitational forces into millions of small pieces. That fateful event marked a turning point in Earth's history, allowing our mammalian ancestors to thrive and giving rise to the evolution of our species. Without Jupiter, our species probably wouldn't exist. But neither would Earth as we know it. The gas giant freed up part of the solar system from older planets, making space for the formation of new planets, including our own. Jupiter might also be the cause of the absence of the ninth planet hypothesized by scientists, which might be hiding somewhere beyond Neptune, but not Pluto. Our solar system is divided into three distinct zones: the inner planets, the outer planets, and everything beyond the mysterious planet. The ninth planet could be as large as Earth or Mars and, over time, wandered among the gas giants before they pushed it toward the outer reaches of our solar system or even deep space. The colored bands on Jupiter's surface are due to differences in temperature, atmospheric gases, and chemical composition. Scientists initially thought these different colors were due to intense atmospheric activity and material circulating between atmospheric layers. Now we know that the light-colored stripes, called zones, show us where gas is rising toward the surface, while the dark stripes, called belts, indicate gas descending toward the core. Jupiter's moons might also be the reason why the planet has these characteristic stripes. The gravitational attraction of the moons would interfere with convective cells within its atmosphere. At the center of Jupiter is a dense, liquid core made of metallic helium and hydrogen and other heavier dissolved elements. As you move away from its center, the temperature and pressure inside the planet decrease. In this way, the liquid interior gives way to gas in the atmosphere, mainly composed of helium and hydrogen. No one knows how deep this liquid-gas boundary is, but the planet is likely completely liquid for about 3,500 kilometers below its clouds. If we could remove its gases, Jupiter would still be larger than other gas giant planets like Saturn. Jupiter is sometimes called a failed star, a definition that isn't entirely correct. Despite being mostly composed of hydrogen, it isn't massive enough to trigger thermonuclear reactions in its core that would turn it into a true star. In theory, any object could be turned into a star if it had the right mass and volume. With significant mass, internal temperature and pressure would increase, triggering thermonuclear reactions. Jupiter's mass is crucial to its identity. To become a star like the Sun, Jupiter would need to increase its mass by about 1,000 times. This would turn it into a red dwarf, a smaller and cooler star. To become a red giant, like Betelgeuse, it would need to increase its mass by about 80 times. However, Jupiter isn't destined to become a star in this way. If it were to significantly increase its mass, it would need to eat other space objects with similar mass. This scenario is theoretically possible but highly unlikely. Jupiter has already engulfed much of the material in the solar system during its formation and subsequent migrations. Additionally, Jupiter's gravitational attraction mainly captures comets and asteroids, which are too small to significantly increase its mass. So, Jupiter will remain a gas giant for the rest of its existence. It will continue to orbit the Sun, influence its neighbors with its gravity, and fascinate humans with its beauty and mysteries. Besides its role as a cosmic giant, Jupiter could have another important function for humanity's future. Some scientists speculate that Jupiter's moons, particularly Europa and Ganymede, could harbor oceans of liquid water beneath their icy surfaces. If confirmed, this discovery would open the possibility of finding extraterrestrial life on these icy moons. Jupiter, the giant that shaped our solar system, could then be the key to our future beyond Earth. In conclusion, Jupiter is a fascinating and complex planet with a turbulent past and an uncertain future. It continues to be the subject of study and discovery by scientists, reminding us of the vastness and wonder of the universe that surrounds us. Thanks for watching. Like and subscribe to support us.